Hey, and welcome back to Mr. B's math class. Today we're going to look at 7.4, solving problems involving prisms and cylinders and volume. Let's take a look at our student outcome for today. So our outcome today is after this lesson, I'll be able to, quite simply, solve problems involving right triangular prisms, rectangular prisms, and cylinders. So let's look at our first example. So example one here is looking at a triangular prism, as you can see from that Toblerone bar. And the example says, Tatiana is stacking Toblerone bars to make a giant triangular prism. In total, she will stack 64 bars. What is the total volume of her display? So we know we've got one bar here. We want to know if she stacked them all into one giant triangular prism, what would that total volume be? So if you want, you can give this a shot yourself and then pause it and come back and we'll go through the answer together. Okay, well, let's take a look at how this one is solved. Well, we know that the area of the base times the height of our prism equals our volume. So quite simply in this question here, our area of our base, we know it's a triangle. So we have a triangle is our base area. And that we know is base times height divided by 2 multiplied by the height of our prism. Well, if we look in here, our base of our triangular prism is 5.6 centimeters. Our height of our triangle, not the prism, but our triangle, is 5 centimeters. We need to remember to divide by 2 there. And if we plug in what we know, we've got 20 centimeters. So if we multiply 5.6 times 5, that's actually going to be 28 centimeters squared divided by 2. And we'll just leave this 20 over here alone for now. 28 divided by 2, we know it's 14. So 14 centimeters squared times 20 centimeters. And we've got our area of our base done. And 14 times 20 is actually 280 centimeters cubed now because we have our 3 centimeters. If we were solving the volume of 1, we'd be done. But we've got to remember we do have 64 bars total. So really to solve this, all we have to do is take that volume of 1, which was 280 centimeters cubed, and multiply that by how many bars we have in the display, which is 64. So we multiply that together, we get an answer, total volume of 17,920 centimeters cubed. And that's as easy as that is. It's just solving one and multiplying by how many we need. So let's look at our next question now today. So here we got a bit of a more challenging one involving cylinders. So what it's saying here is that we've got a first cylinder right here that has a radius of 0.6 meters and a height of 15 meters. But they need to replace that with a new cylinder that has the exact same volume. But the new cylinder is going to be a little bit narrower, and it's going to have a radius of 0.5. So if they're going to be equal to each other, we need to figure out what does the height have to be here in order to make that equal. So this one actually will be a multi-step process. So let's look at how to solve this question. Okay, let's take a look at this. So to solve this, step one we're going to do is look and find the volume of our original cylinder, which is right here. And we know that, again, area of the base times height will give us our volume. We know that the area of our base is just the area of a circle. So that should be pi radius squared times the height of our cylinder. Well, we know that pi is 3.14. Now, remember, if you can, use your pi button because it's going to give you the exact answer. I'm choosing 3.14 here because it's universal. Someone doesn't have that button, but if you do have it, please use that because you get a more exact answer. Our radius is 0.6 meters, and squared means we're going to times it again by itself, 0.6 meters, and multiplied by our height, which is 15 meters. If we multiply all of this together, our area of our circle, which is right here, times it by 15 meters, which is our height, we get an answer of 16.956 meters cubed. So now we know the volume of our original cylinder. Now we need to write down what we know about the second cylinder. Well, we know the volume of that second cylinder is going to be the same as the first one because in the question it mentioned they're both the same volume. So we know the volume is going to be 16.956 meters cubed. And we do know that the radius is 0.5 meters. What we don't know is our height. We're not sure what that height is going to be. But now we know what we've got to work with. So for step 3, we're going to put what we know into our formula. Well, we know the volume of a cylinder is going to be volume equals pi r squared times our height. Well, good for us that we actually do know the volume. The volume is 16.956 meters cubed equals, we know that pi is 3.14. We know our radius is 0.5 times 0.0, and that's meters, I apologize. I'm going to erase that quick. There we go. Times that by 0.5 meters. Times it by our height, because we still don't know it. Well, if we just quickly take care of that ourselves, we'll just do what we can here. We can multiply this part together. So really, I'm just going to move everything here. Our volume will stay 16.956 meters cubed equals, and I'm just going to solve this to get this kind of a more simple number. So we'll solve the area of our base, which is pi times 0.5 times 0.5, which should give us an answer of 0.785, I believe that's correct, yeah, meters squared, but we're still timesing it by our height because we don't know what that is. Now for step 4, we're just going to try to figure out how to get this variable, because we don't know what height is, on its own alone here. So what I'm going to do is use division. So if we look here, what we've written down is our volume is 16.956 meters cubed equals 0.785 meters squared, so that's our area, times our height. Well, I want to get this alone, so I'm actually going to divide by this number to get it out of the way. And when I do to one side of the equation, I always do to the other. Divide by 0.785 meters squared. Well, 0.785 divided by that itself will actually cancel it out. And now we're left with just h on its own. And all we have to do now, quite simply, is just divide our volume by our area of the base. If we divide 16.956 by 0.785, we actually get an answer of 21.6 meters. Now it's only meters because you can see right here, we've got meters cubed and meters squared. So really what we can do with those units, right, meters 3 and meters 2, well, it's like we subtract them. So 3 minus 2 is 1, which means all we have left is that 1 meter on its own because it's just meters. And that is the answer. It's 21.6 meters equals the height. So whenever you're not sure and you have something missing later on in your formula, plug in what you know and try to isolate that through division, and that'll get you the answer. So that is all that is here for our lesson today. We'll chat more in class about this tomorrow, as there are a few other types of problem-solving questions we can do. But just remember, first and foremost, always write down what you know and what you're looking for. All right, I'll see everyone tomorrow in class.